Okay, so we're looking at page 20 in the packet, and we're starting Unit 2 on probability. Well, 21 actually. 20 was just the title page. So, in order to understand probability, we got to sort of start speaking the language a little bit. So, probability is a branch of math that deals with the chance of an event occurring. Most people know that. That's a term that you're probably familiar with. But some of the other terms, event and sample space, maybe not. Right? An event is a collection of outcomes of a procedure. Right? So the sample space is the list of all possible events in an experiment or an activity. So if I'm talking about, for example, I'll keep it kind of simple. Talking about shirt colors from the set of red, blue, green, and yellow, this would constitute a sample space. All right, so those are all the possible outcomes that we might have. All right, so is that an exclusive sample space? Probably not. I mean, those are just the colors that I have, for example. Yeah, well, I'm wearing an orange one right now, so I'm already kind of breaking my own example. But an event might be just simply blue, or it might be green, or maybe it's a combination of things like red and yellow. All right, so maybe it's a shirt that's got a little bit of both. You know, like all sorts of different possibilities. But if we look at an event as a subset of a sample space, that's probably a good way to think about it. All right, so we usually use the beginning of the alphabet if we're kind of encoding events. You know, event A, event B, event C, things like that. Where P parentheses A represents the probability of event A occurring. And that little tilde represents the probability of it not occurring. All right, that's also known as the complement. Complement of A. All right, so complement, not compliment. All right, so it's not like, oh, looking good, eh? How you doing? You know, it's more like the complement as in what is associated with the A, what's left over after we've accounted for A. All right. So a few different ways we can come up with probabilities. You know, now that we have a little bit of a sense of the notation, one is the experimentation method. So if I'm talking about finding the probability of getting heads when you flip a coin, one way to do that, and I don't think it would be too much fun, would be flipping a coin a large number of times, maybe like 100,000 times, and seeing what the probability, as in like how many times you got heads, divided by the number of possible outcomes. All right, so if I flip the coin 100,000 times, I would expect about 50,000, you know, give or take a couple, to be heads and the rest to be tails. All right. There's also a formulaic approach where we say the number of ways that A can occur, that would be event A, you know, some arbitrary event, over the total number of possible outcomes, so that would be the sample space. All right. So this is really saying the event, and this is saying the sample space. Which kind of, you know, begs the question, how can we determine the total number of outcomes in the sample space without actually having to list the whole thing? You know, because sometimes it could get a little crazy. All right, that's going to be part of our investigation. All right, number 3, the third approach, estimation pattern recognition. Say this is the least frequently used method mathematically, as in like in a math class. But in the real world, You haven't seen what I've seen. It happens all the time. You know, it doesn't always involve data analysis, but I'll tell you right now. I mean, I don't live in the city anymore, but I knew where I needed to stand on that subway platform in order for those doors to open right in front of me. Otherwise, maybe I wasn't going to get to work on time. How did I know that? Observation. I had to get it wrong a few times, of course, but eventually I got it down, and it started to become a pattern that I could recognize and then say, oh, all right, if I stand in this very spot, I'll be good to go. If not, I'm screwed. So there were times where I'd see a train coming in, and I'd be like, you know what? I'll catch the next one. Because even though I could get a spot right at the edge of the platform, it wasn't the ideal spot. So I was like, you know what? Let me just hang back, let everybody else kind of scurry and try to squeeze in there. I'll get the prime spot, and I'll be the first one on the next subway. All right, but that's estimation pattern recognition. It happens all the time. Just how do you quantify that in a math class? How do you say number over another number? Like Charlie is commuting to work on a daily basis. That would be one hell of a word problem. The word problem would be an essay. It would take some time, obviously. Weather prediction. There's a 30% chance of rain. Where are they getting that 30% from? It's from probability. Right? Basic probability rules. Any probability value has to be between 0 and 1, unless it's in percent form, in which case it would be between 0 and 100. But we're not typically going to be working with percent forms. In fact, the only time you would be dealing with percents when it comes to probabilities if the question told you to put your answer specifically as a percent. All right. 0 is the event is impossible. 1 is the event must happen. Right? It's a very important distinction. It's not that the event didn't happen, it's that it can't happen. So that's what impossible means. It means it cannot happen. So it's not like I flip a coin 10 times and I just didn't get any heads. I would not then say the probability of getting heads is 0. That's not true. But if I said flip a coin 10 times and the two outcomes that are possible are heads and tails, what is the probability of getting a banana? Then I would say 0 because it's not a possible outcome. All right, so hopefully that gets the idea across. The complement rule, it's fancy notation, but it's basically saying that if you add two complements, the probability of two opposite events together, the result should be equal to 1. So I kind of look at it like in real life terms, real life, simple real life terms. But I could say the probability that it will rain, so I'll say example, plus the probability that it will not rain would be equal to 1. And that would be something that you could look at as a true statement. That's reasonable. Probability that it will rain plus the probability it will not rain is equal to 1. All right? So if I tell you there's a 30% chance of rain, then I'm telling you that there's a 70% chance that it's not going to rain. And you'd say, well, what if it snows? And I'd say, well, that's not rain. All right, what if it's freezing rain? Well, you said rain right in the name, so that's rain. So it's either rain or it isn't. All right? And in a lot of cases, what the challenge is going to be is to take situations that don't seem to be what we call binomial or binary and make it binomial or binary, where we're kind of categorizing it as one of two possibilities. You're either with me or you're agin me, that kind of idea, where it's like not male and female, but male and everyone else. Not up and down, but up and everything else. All right? And you'd say, well, isn't everything else necessarily down? Well, no. I mean, you could stay put. So that's allowing for a catch-all to capture every other possible outcome. So in the simple example, given a multiple choice question with 5 choices, what is the probability of getting the correct answer by guessing? Well, 5 choices. You got to assume one of them's right? I mean, that's how multiple choice questions work. So the probability of getting a correct answer simply by guessing. Well, there's one correct and there's 5 available, and there it is. What's the probability of getting incorrect? Well, that would be the same as saying not correct. So I just drew a little tilde there to represent not, or the opposite, or the complement. All right, it's poor quality tilde, but it's still a tilde. All right, some people think that I'm drawing an N here. That's a function of my lousy ability in penmanship. It kind of looks like an N, I suppose, but if you look at the keyboard here, it's this symbol. All right, it's a tilde. So 4 over 5, because there are 4 incorrect answers and there are 5 questions in total. So we want to verify a complement rule. The complement rule says if I add the probability of 2 opposite events occurring, so I should get a result of 1. So I'd be looking to write, probability, I'll write C so I don't have to write correct again, plus the probability of not C should be equal to 1. 1/5 plus 4/5. Well, that's equal to 5/5. That is equal to 1. That checks out. You can do it in Desmos too if you don't feel like doing the work or the thinking. Take a little mental break. Result 1. All right, so it checks out. So we're in good shape there. So we have a nice little rule that we can rely upon. And that rule is going to be really helpful moving forward, because what it's going to allow us to do is possibly take some situations that seem complicated and make it less so. Right? So that's a good thing. That's what we're looking for. All right. The last thing on this page is the rounding rule. We want to go to 3 significant digits. Here's a couple examples of 3 significant digits. So in the case of the 0.2380017, we're just rounding after 3 decimal places, and that's it. All right. When we're rounding to 3 significant digits, what we're doing is we're taking the first 3 non-zero decimal places. All right. So that kind of seems complicated, but it's really not. It's basically look at the decimal point and travel to the right from there, and if there's a string of zeros, ignore those. All right, so ignore the zeros. When the zeros stop, that's when you start counting off your 3. You say, okay, I have 1, 2, 3 decimal places after the string of zeros stop. So then I round appropriately from there. So then you use your classic, if it's 5 or above, give it a shove. If it's below, let it go. 9 is going to round the 0 up to a 1. And so you get the 0.0000721. Right. So I put the little disclaimer at the bottom there. If you don't like that, you could always stay in fraction form. All right. And so you can kind of look at it like, for example, if I want to do something like this, 1/5 plus 4 over 52. We get this disgusting decimal. You could round this, 0.277 is what it would be. Or you just tap on the little fraction icon and make it a fraction and go from there. Right?